So here we're going to be proving that lines are parallel. And in order to do that, what I want to do is I want to start with this constructed line L and point P. And I want to see if I can construct a parallel line in more than one method, really, for me. But I want to see that we can construct these parallel lines and kind of prove it as we go. So what I'm going to do is I'm going to really just construct an angle. And when I construct this angle, I'm going to be lazy and I'm going to run it from the end of the line L through point P. And I'm going to let that new line go ahead and exist. Now this angle, whatever it is the angle that I'm going to go ahead and try and recreate right here. I'm going to try and create corresponding angles. What I'm actually going to be using is the converse to the corresponding angle theorem. In all of the theorems that we talked about in the last class, there are converse to these particular theorems. So you just have that, instead of given two parallel lines, what we do is we start with given two congruent angles. So I took a distance from here and that same distance from P. Now what I'm going to do is I'm going to use my compass to measure my arc from line L to the line that goes through P. So that is the radius of a circle, and I'm going to go from this line in that other direction. So now I can make a straight line from P through that intersection that I've created. And when I do this, I seem to be a bit off. My measurement's bad. That's always embarrassing. Oh, I didn't tighten my parts. My compass was loose. That's never good. So when I take that measurement, I can transfer the measurement again to that line down here. And that looks a bit better. So ignoring the first point, we're already seeing in these videos, mistakes are going to be made. Don't be afraid of them. I'm certainly not. Look at how many I make. So I'm going to connect these two lines with a line. Now what I've got is that this angle right here, I'll call angle 1, and this angle 2, angle 1 is congruent to angle 2. And when angle 1 is congruent to angle 2, then what I've done is I've created a new line, Z, and this new line is parallel to my original line, L. Now this is using a compass and straight edge. The truth is I like to be lazy, and since I like to be lazy, I've made a trace of my original line and my point. So I'm going to instead try and do this in a different way, using a bit of origami. So I'm going to just fold this line over on itself so that point P is on my fold of the paper. And back when early in this series, I was talking about constructing perpendicular bisectors. Now I don't know if I bisected my line, but I do know that it is perpendicular. So this new line here that goes through P is perpendicular to line L. So if I fold the fold onto itself so that I go through point P. So now my fold has to, and I have to come off camera a second because I can't do it with my old eyes. So that my fold goes through point P. Now my new fold is parallel and goes through point P. So to make it stand out some, I could just simply trace over it with my straight edge and a marker to help this stand out. What I get is a new parallel line using a paper folding technique. It's a quick way, especially when you're dealing with on tests, and I tell my students to put paper up to a computer to be able to do that. So what happens if I'm given two angles that are parallel or that are congruent to each other, like angle 3 and angle 5 in this new problem? If angle 3 and angle 5 are congruent, how can I prove that L is parallel to M? So what I'm going to do is I'm going to start by just simply saying that angle 5 plus angle 6 is equal to 180 degrees. That's because they are supplementary angles to each other. I know that the same side interior angles, so I'm going to just call that the definition of supplementary angles. I know that same side interior angles says that angle 3 plus angle 6 is equal to 180 degrees. So I'm going to just simply run a substitution, and I'm going to say that angle 5 plus angle 6 is equal to angle 3 plus angle 6. Using the subtraction property, I subtract angle 6 from both sides, leaving me with angle 5 is congruent to angle 3. Now I guess if we wanted to be fancy and make sure that we said 3 congruent to 5, we can use the transitive property just to be able to say angle 3 is congruent to angle 5. So there we're able to apply these same theorems in ways to prove backwards using their converse. So we had an original theorem that simply gave us that if we have P, then we have Q. And that would be the theorem itself. A converse of it is when I just simply switch the P and Q. So I can say if we have Q, then we have P. And we've applied some of the converse theorems here. The converse theorems as they apply to the last video is that we have the converse to the same side interior angle, we have the converse to the alternate interior angle, and the converse to the corresponding angles. So if you just look back at those, you'll see that instead of provided two parallels, we create angles that are congruent, but we start with two congruent angles, and we can make two lines that are parallel. Remember, math rocks with a capital M.